So the word is soyuz. How many letters grand total? So it's going to be 7 factorial over. How many O's? How many S's? Don't write S's, Mr. Dueck. 2 factorial. Now, that's how I write it. How do I type that into my calculator? I'm going to have to add some timeses and some brackets. First of all, I have to put my calculator into factorial mode. Again, you need to make sure you know how to do that. How many things are on the top? No, how many? 1, so you know what? 7 factorial, no brackets, divided by more than one term on the bottom. And I have to go 4 factorial. I have to put a times there. 2 factorial. If you do that, you won't get an error. If you don't put the times in there, you'll get an error. So 105, I hope that's the answer. It should be the answer. Okay. So this is why you're going to hear me go on my rant. Get your calculator. Try this, because there's all sorts of little tweaks that you need to figure out for your particular calculator and how to enter these. Any others from the homework, please? Ben?
6.
6. Julia?
7.
6 and 7. Okay. 6A, 6B, or both?
Both.
So 6, first one, I'm going to ignore the algebraic method. I said I can use permutations. So it seems to me I'm going to go right, 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 down, down, down. It seems to me the number of pathways, it's a 7-letter word with how many R's?
4.
And how many D's? That's going to be the answer.
Okay.
Now, for the second one, draw that a little better, Mr. Dueck. I'm going to have to do it twice, because it's going to be how many ways to get from A to C, and how many ways to get from C to B. So it's going to be a multiple kind of a thingy.
Okay.
It's going to be 8 factorial all over 4 factorial, 4 factorial. That's the first square. And 5 factorial all over 3 factorial, 2 factorial. I think that'll be it.
All right. Thank you.
Yep. What's sitting right here? What does and mean? Times, right? And again, this is why, Mackenzie, I said we have to go from A to C and C to B. Not or. I have to go through C and. Julia, did I just answer you for number 7 as well? Because it's going to be the same as 6 part 2.
Yeah.
Okay? For what it's worth, if you want the setup, it's going to be 2 factorial over 1 factorial, which I'm not going to bother writing, but that's the first little square. And 4 factorial over 2 rights, 2 downs. And 5 factorial over 3 rights, 2 downs. Whatever the heck that works out to, type it in carefully with brackets and stuff. Is that all right? I like that question. I like that question. I like that question.
Question gonna be on the test?
Pathway questions are neat. It's a neat, nerdy application. This is also an application to network theory and linking theory. So instead of little pathways, start thinking airline flight setups and things, and you can start to see where they might use this. And you also start to see why the numbers get so big so fast. Yeah.
Do you like that question?
Maybe. Any others from the homework? Yeah, Taylor. 4A. Okay. It says there's 8 runners. How many orders? So first of all, when I see how many orders, that's a permutation. That's going to be a mixing up. I'm not going to do 3A as written. Instead, here's what I see. Oh, hang on. 2 Canadians, 1 Russian, 1 German, 1 South African, and 3 Americans. I see a word. How many letters is that word grand total, Taylor? It's going to be 8 factorial over 2 Canadians, 3 Americans. I could ignore the 1 Russian, 1 German, 1 like that. And this is why we start out doing so many words, because Logan, with a bit of cleverness, I can turn lots of questions into words. Yes, it's runners. No, they're letters. As far as I'm concerned, I can treat them that way. Is that okay? And I'll let you try B on your own. Any others? right there.
No, like, that's 6-2, like 6B.
Well, no, 6B is
Oh, okay.
doing it with permutation. I skipped 6A because there's another method to get there using what's called Pascal's triangle, and it's nerdly cool, but I didn't teach you that. I was going to, but with a late start, since it's not officially part of the curriculum, it's nerdly cool, but no. Any others? Okay. Can you please, on that note, turn to the next lesson, which is lesson 5. You're going to want your fancy schmancy handy dandy calculators handy. Lesson 5, page 95. Under the B, 9. Under the I, 5. Under the classroom, shush. Thank you. Okay? So, Karn, can you see the difference between the two examples that I was talking about there? We're saying, hey, a permutation is going to count when you get picked. It's going to take that. The order matters. But if the order doesn't matter, we call that a combination. In fact, by the way, they shouldn't be called combination locks. On your locks, does the order that you enter the numbers matter? They should be called permutation locks. Okay? If I was a math nerd, I would fix that. You all have permutation locks, not combination locks. Read along with me. As part of the grade 12 English course, students are required to read the following 3 books in a 3-month period: The Grapes of Wrath, The Wars, and The Bean Trees. Due to previous late returns, Steve is only allowed to sign out 1 book per month. Steve's bad. It says, list all the 3 different orders in which Steve could sign out the 3 books. I don't want to list them, but I would like to say how many different orders can he sign out the 3 books. I can do that in several ways. I can first of all draw a blank. I'm good at drawing a blank. The first month, how many books does he have to choose from? He reads 1 of them. The next month, how many books does he have to choose from? He reads that, another one. The next month, how many books does he have to choose from? Can you tell me a shorter way to write that? Tell me another way to write that. As a number, but can you tell me another algebraic way to write that? From 3 objects, permutate all 3 of them, because that'll also give you the same answer. Okay? 6. Tariq is allowed to sign out all 3 books at the same time. I don't think you care about the order that he signs, or she, I think Tariq is a male, signs the books out. I think all you care about is did they read them or not. So how many different ways? Only one way can you sign out all 3 books at the same time. Part A is an example of a permutation where the order changes the question. Part B is an example, and here's our word of the day, of a combination. Order is not important. Okay? You don't care when you get picked. You only care if you get picked. A selection of a set of elements in which the order is not important is called a combination. Part 2 says, suppose the students were required to read only 2 of the books. It says, complete the table to show the number of ways in which Steve and Tariq could do this. I'm not going to complete the table. Instead, I'm going to see if I can figure out a better way to do this. Okay? So we'll come back to this. We will say this A permutation is an arrangement. You may recall, I think in the second lesson, I said arrangement was a trigger word. If I see the word arranged or arrangement in the question, that's a permutation. Otherwise, I have to think about it. I have to say, is it different getting picked first than getting picked second than getting, that's still an arrangement, permutation. If they just want to know picked or not, that's a combination. So a permutation is an arrangement of elements in which the order of the arrangement is taken into account. The shorthand version for this is order matters. A combination is a selection of elements in which the order is not taken into account. We only care in or out. Picked or not. Yes or no. Turn the page. Five students, A, B, C, D, and E. Yeah, we picked the names on purpose that way. Oh, are you suggesting that I can form a word? Yeah. Take part in a cross-country race. Suppose the winner wins $50, the runner-up wins $25, and the third-place runner wins $10. Does the order that you finish in matter here? Because first gets different than second gets different. So this is a permutation. The table below shows all the possible ways in which the prizes could be awarded. A stands for Al, B stands for Byron. So we turned it into a word. This is all the possible permutations. In fact, this is an example of a permutation. How many ways are there? Count. Or don't count. Can you multiply, please, by going length times width?
60.
Is it 60? Now, we should also have been able to go from 5 permutate. How many are we permutating at a time? How many are we permutating at a time? Taylor, check on your calculator. Is 5p3 60? Or we could have drawn a blank. Or we could have said, hey, you're picking 3 people. You got 6 different ways to pick the first winner. That leaves 5 different ways to pick the second winner. 4 different ways to pick the third winner. All of those are acceptable. You should be able to be comfortable with all of those approaches. The stupidest one, the worst one, is this one here, listing them and counting. But we're making a point this time. So how many ways are there to award the prizes? 60. I'm going to change this question. Well, no, this works. Okay. For participating in the cross-country race, the school has been awarded 3 places at a running clinic. The school coach gets to select the lucky 3 students from the ones who took part above. So here's the same table as before. For which one? For B? Isn't it? Oh, 5 times 4 times 3. I'm sorry, Brendan, you're right. Yes, he gets a candy. Here you go, sir. Uh-oh, I'm almost empty. Time to go shopping. Sorry, guys. 5 times 4 times 3. Thank you, Brandon. By the way, if I make a mistake like that, point it out and give him an elbow for me, please, Giancarlo. Thank you. Give him an elbow for me. Needs to be awake. So, part B. Here, the top 3 are going to go to the cross-country race. We don't care what order they finish. We just want to send our top 3 in or out. First, second, and third are going. You can treat this like a word. How many kids are going? You can say that's like having 3 yeses. 3 kids are going. It's like having 3 ins, 3 picks. How many kids are not going? You can think about part B, instead of listing all of them, which I think is an ineffective way to do it. I think, Hannah, you can say, you know what? If we're just going to send 3 to the next, we don't care when, just the top 3. 3 of them are in the top 3, 2 of them are not. That's a word. How many letters in that word? How many ways can I mix up that word? Over. How many Y's?
3.
Now, I'd like you, where I wrote 5p3 up here, beneath it or beside it or above it, to realize this is really 5 factorial over 5 minus 3 factorial. That's from your formula sheet. That's the definition of a permutation. By the way, what's 5 take away 3 in your head? Okay, this is really 5 factorial divided by 2 factorial. Can you see why that gives you the 5, 4, 3? Because the top is 5, 4, 3, 2, 1. The bottom is 2, 1. You cancel out the 2 1s, you get your 5, 4, 3. The combination is not 5 factorial over 3 or over 2 factorial. It's 5 factorial over 3 factorial, 2 factorial. This is an example of a combination. How many ways are there to select the 3 students? Can you calculate that for me? What is 5 factorial over 3 factorial, 2 factorial? 40? Is that right? Anybody else? Can I get a confirmation?
I got 10.
10? Is 10? Yeah? You put the bottom in brackets? So what you did was 5 factorial divided by 3 factorial times 2, and your calculators, oh, you want that on the top, right?
You have that bracket to get 40.
Yeah, I know. Thank you. Okay. Guys with me so far? We're going to try now and standardize this. So it says, complete the following statement. The number of combinations is equal to the number of permutations. That's that part. Divided by 3 factorial. That's that part. So, we have this. Don't write this next bit down. For permutations, if you have n objects and you're picking r at a time, right from your formula sheet, it's n factorial all over n minus r factorial. You can write that down if you want to. It's on your formula sheet. For a permutation, if you have n objects, Sterling 12 objects, and you're picking 3 at a time. And remember, here's what you have to memorize. In a permutation, the order matters. Picking first is different from getting picked second, is different from getting picked third. It's, what did I say, 12 factorial over 3 object, 9 factorial. 12 take away 9. For a combination, next page over, it's n factorial all over n minus r factorial. And here is our new equation right here. This is also on your formula sheet. So if you look on the Unit 2 formula sheet, I gave you factorial notation. I gave you the number of permutations with repetitions. And here is, oh, we write it as NC for combination or for choose R. Hey, have you got an NCR button on your calculator too? Mm-hmm. You do, Zach? Well, that's convenient. Is it right next to the NPR button? Don't get them mixed up. Let's do some examples with this. Oh, by the way, in some textbooks, NCR is written like that. I hate that second notation, so I will never use it, because I think NPR and NCR are nice and systematic and sequential. So, 3 students from a class of 10 are chosen to go on a field trip. How many ways can they be selected? So there's 2 ways I can think about this. I can think about this as a word, which is 3 students get a yes. How many students get a no? N. How many letters in this word grand total, Oscar, my friend? Nice recovery. How many Y's, Oscar, my friend? How many Y's? How many no's? So where it says write the answer in factorial notation, that's one way to do it. As I've said, with a bit of cleverness, Grayson, we can turn a lot of questions into words. But recognizing, hey, it doesn't matter whether you get picked first, second, or third. It only matters, Grayson, that you're going on the trip. This is a choose. This is a combination. I could go 10 kids, choose, not permutate, 3 of them. Either of those is your option. What's the answer? I would use the 10 choose 3 myself. What do you get? 120? Anybody else? 120? There's 120 different ways from a class of 10 that 3 kids can go on a trip. Okay. And again, I'm emphasizing, do you see in this case that the order doesn't matter whether you get picked first, second, or third. All the question says is, are you going or not, in or out? Yes or no? This allows us to start to calculate Lotto 649. Lotto 649, the order that the numbers are picked don't matter. You just want to know, did your number get picked or not, in or out? Now, they put them in order when they broadcast them. Okay, they go from smallest to biggest, but doesn't matter what order they picked them in. You just want to know, did my numbers get picked? So to win Lotto 649, a person must correctly select 6 numbers from 1 to 49. Jasper selected 6 numbers from there. How many different possibilities are there? How many numbers are there in Lotto 649? 49. Choose. To win the grand prize, how many do you have to pick? How many different possible ways are there? How many different possible combinations are there of 6 numbers? This one's going to be big. 13, 98, 38, 16. $13,983,816. Of those, how many are the right one? Chance of winning, 1 in 14 million. If you're wondering where it comes from, there it is. Okay? It's 13,980,000, but it's just below 14 million. Chance of winning the grand prize is about 1 in 14 million. Now, we want to go even further. We want to break them up into subgroups. So you ready? I like example 3, I like example 3, I like example 3.
Example 3 going to be on the test?
Absolutely. Okay? The athletic council decides to form a subcommittee. Guys, this is important, please. The athletic council decides to form a subcommittee of 7 council members to look at how funds raised should be spent. How many people are we choosing grand total? 7. But they're going to attach a condition. They're saying you have 9 males and 6 females, and the subcommittee must have 3 girls. How many guys then? 4 guys. Here, for combinations, this is the best tool I can give you. If, for the fundamental counting principle, it was draw a blank and Scrabble bag, Here is what I use for all combinations. It's the notion of a bucket. Put your pencils down and watch. Don't tune out. Give Ty an elbow. Okay? Here is my, this helps me figure out a lot of combination questions. First of all, I'm not going to do that or that. I'm going to go straight to the answer. I'm going to draw a bucket. The bucket consists of males and females. How many males are there grand total? How many females are there grand total? How many females must be on the committee?
3.
How many males must be on the committee then by default if we're having to put 7 people on there?
4.
You want to know how many different committees I can make with 4 guys and 3 girls if I have 9 guys to begin with and 6 girls to begin with? 9 choose 4 and 6 choose 3. Can you see where I got that from? From the bucket. So now write down the bucket, complete with the arrows. Then write down the calculated answer. And then crunch the numbers, please. You get 2,520? 2520? Check and see if you get that. You need to know how your calculator works, right? Okay. In part B, in how many ways can the subcommittee be selected if Bruce, the football coach, must be included? Okay, now we have to have Bruce. How many ways are there to pick Bruce if he has to be on it? It's meant to be a really obvious trick question. 1 way. And how many males are now left in the bucket if we picked Bruce because he has to be on the committee? How many females are now left in the bucket? 6. How many males must we choose? So Bruce has to be on the committee. How many females did we say have to be on the subcommittee? Of the 8 males, how many are we going to be choosing? Yep.
Adding Bruce to the subcommittee, would that not change the actual number of males in the council? Like, wouldn't that number still be 9, but you just take 1 less?
I did. That's where the 8 came from. Right? 9, 8. There you go. Good reinforcement. So it's going to be 1 times. Am I going to bother writing the 1 times? What choose what? What choose what? Yeah. Now, here's what we're really saying, by the way. 8 choose 3, choose the males. And what does and mean? So that's why and means multiply. From 8 males, choose 3 of them. And from 6 females, choose 3 of them. If Bruce has to be on the committee, how many committees can we form? Pardon me? Politics. Anybody play poker? Okay. In poker, Mark, in poker, you don't care when you got the ace. You only care if you got the ace. Cards, hands of cards, are chooses, are combinations. Let's look at some. Next page. I'm going to ask you card questions because I think they're a neat application, and also it leads me, when we do probability, we can start to look at gambling odds. But the only way that works is if you actually know what a deck of cards looks like. So in a standard deck of cards, How many cards are there grand total?
52.
52. How many weeks are there in a year?
52.
It's not a coincidence. Oh, really? How many seasons are there in a year?
4.
How many suits are there in a deck of cards?
4.
Not a coincidence. Anyways, 52 cards, 4 suits. How many in each suit then? Whatever 52 divided by 4 is 13. Okay? How many cards are black? 26, half of them. How many cards are red? 26, half of them. What's a face card? More specific. Sorry? Can you go in order from smallest to biggest? So, how many face cards are there in the deck? Grand total?
12.
12. How many black, you guys with me? How many black face cards are there?
6.
6. How many red face cards are there?
6.
How many face cards are hearts?
3.
3. Okay. You need to be a little bit familiar with navigating your way through a deck of cards. I am absolutely going to ask you card questions. A, because, hey, gambling, I can teach you how not to do it. And most of you have played with cards. Now, I do have to point out, in the old Math 12 course, they were forced to remove card questions from a provincial exam because there are people that have a particular religion or conservative background that don't like cards, and so that was removed. If it does offend you, I apologize, but I'm going to do it anyways. Okay? You ready? So, poker is a card game from a deck of 52 cards. How many 5-card poker hands are possible? Now, again, pause the video for 1 second. How many different 5-card poker hands are possible? How many cards are there in the deck?
2.
Choose. How many am I choosing?
5.
Okay. How many? By the way, the trend right now is 7-card Texas Hold'em, and we can do that, but it just gets really big really fast. I'm going to stick with 5-card draw.
2,598,960.
2,598,916. I know it's about 2.6 million, just shy of 2.6 million.
Yeah, I said 60, not 16.
60?
Yeah.
Okay. All right. Do you remember what I said was the most useful tool that I can give you in the combinations? The bucket. So you ready? We're going to use a bucket approach for each one of these for a very good reason. If you ask me a homework question and you haven't drawn the bucket, I'm going to turn you away. Okay? Taylor, is it working okay? You guys are all staring at the calculator. Are you having glitches? Is it Oscar or is it Taylor? Taylor? Figuring it out or not? Hang on, let me hit pause. I'll come help you. So, I'm going to zoom in. How many of the hands will be all diamonds? What I'd like you to do over here is draw a little bucket like that. And we're going to have this. Diamonds and not diamonds. Now, who can remember from set theory what the symbol was for the complement, which was the opposite of? Isn't that handy? How many diamonds are there in the deck? How many non-diamonds are there in the deck?
39.
How many diamonds do I want to choose? Trick question, how many non-diamonds do I want to choose? What's the equation going to be? What choose what times what choose what?
13 choose 5 times 39 choose 0.
Stop. Can all of you right now go 39 choose 0 on your calculator? Ignore the 13 choose 5. What is 39 choose 0? What's 50 choose 0? What's a million choose 0? What's anything choose 0? Since it's a 1, if you are lazy, you can skip typing it. but I put it there for a reason, because this question said all diamonds. What if I had said 3 diamonds and 2 non-diamonds? Looking at the bucket, can you tell me what it would be? If I wanted 3 diamonds and 2 others, 13 shoes and 39 shoes. So the method that I'm giving you, Kyle, is very, very easily adjustable. Anyways, how many ways are there of getting all diamonds? Sorry? 1,287, is that right?
Yep.
By the way, what do you call it when you have all of the same suit? A flush. Good hand or bad hand? Pretty good hand. Big number or small number? Small number compared to that 2.6 million. That's why it's a good hand. You can't get it very many ways. 2, 4 black cards and 1 red card. 4 blacks and 1 red. Good hand or bad hand? This is a nothing. I'm expecting a fairly big number this time. That's not what it says. 4 blacks, so that could be a couple of spades, a couple of clubs, could be 3 clubs and 1 spade and 1 red. So, bucket. Here, we're going to have black, and I could go B apostrophe, the opposite of black, but in a deck of cards, what is the opposite of black? I'll go B and R. How many black cards are there in the deck? Grand total? 26. How many red cards are there in the deck? 26. How many black cards do they want me to choose? How many red cards do they want me to choose? 1. Can you see what my equation is going to be? What choose what? What choose what? 26, choose 4, and, so pick 4 black cards, and pick 1 red card. This should be, I'm going to guess an answer in the tens of thousands, or possibly even in the hundreds of thousands, because this is a sucky hand. 388, what? 388-700?
Yep.
Okay. And again, Pam, here's numerical proof as to why that's a lousy hand, because you can get it a lot of different ways. 3. 3 kings and 2 queens. Good hand or bad hand? Pretty good. This is a full house. So am I expecting a big number or a small number? Is a full house better than a flush or worse than a flush? Full house is better than a flush? It's not. Flush is better than a full house. So I'm expecting a number bigger than 1,000, whatever it was from part A, probably in the high thousands or tens of thousands. Full house is better than a flush? I don't believe so.
Which is better, flush or full house?
You know what? We're going to find out right now, mathematically. Why did I draw 3 chambers in my bucket? What's the first one? Kings. How many kings are there? Yep. What's the second one? Queens. How many queens are there? No. How many queens are there grand total? 4. What's the third one? I have to, in my bucket, I have to have the entire deck. Okay? So this is going to be king, queen, not. How about KQ apostrophe? How many non-kings and queens are there? I think you can figure it out by doing some subtraction. 44, because I got 4 cards already in my bucket, and there's a total of 52, so I got 44 others. Now, how many kings do I want? What's the question say? How many kings? 3. How many queens do I want? How many others do I want? Trick question. None. But again, can you see with this bucket, Logan, I could have said 3 kings, 1 queen, and 1 generic card. It'd be easy to tweak. What choose what? What choose what? What choose what? 4 choose 3, 3 kings, and 4 choose 2 queens, and 44 choose 0. By the way, what is 44 choose 0? 1, so I won't bother typing it into my calculator. But I kind of like writing it because can you see there's some nice symmetry. If you add up the first numbers, you get 52 cards. If you add up the second numbers, you're picking 5. So it gives me my error check. Yo.
I'm a bit lost because it says that there's 13 cards in each suit.
Yep.
You're saying that there's 4 kings and 4
So 1 king in each suit. How many suits are there?
queens.
No, how many suits are there? Okay, so there's 4 kings. King of clubs, king of spades, king of hearts, king of diamonds. So how many kings are there in a deck? 4. That's where the 4 came from. How many queens are there in a deck? 4. Okay. How many clubs are there in a deck? 13. How many spades are there in a deck? 13. Okay. Don't feel bad. Every year I go through this. You'll get good and you'll figure out a deck of cards. Mr. Dueck, could you do like a poker? You know what? If we hadn't started the year late, part of my plan was to do a little poker day because it's a great way to get familiar with a deck of cards. Sorry, I can't. I might do it on the final Friday before Christmas, but I'm not here the final Friday before Christmas. I'm with the basketball team. So, sorry. I would if I could. Because gambling is good math. Well, actually, gambling is bad math, but it's useful, right? Hey, what do you get? 24? Wait a minute, Mr. Dueck. I thought you said a flush was better than a full house. This is one particular full house. If I wanted to find the total number of full houses, I'd have to go 3 kings and 2 twos, 3 kings and 2 threes, 3 kings and 2 fours. There's a better way to do it, but I could either list them all systematically, or maybe there's a way I can count them without actually counting. Let's keep going. 3 kings. What do you call 3 kings? 3 of a kind. Although this is 3 of a kind, king high. No, 3 kings and what generic cards. Bucket. What's my bucket going to be? Kings, but I have to have the whole deck in my bucket. So I guess others. How many kings are there in the deck, Julia?
4.
Yes. How many cards are there in the deck grand total, Julia?
15.
So how many do I have in the remaining chunk of my bucket? What's left over?
48.
Yes. How many kings am I choosing? According to this question, Julia?
3.
Yes. Oh, how many others am I choosing then? Do the math. I must be. What choose what? What choose what? 4 choose 3. From 4 kings, choose 3 of them. And from 48 remaining, choose 1 of them. Choose 2 of them. Sorry. By the way, that's why I do that built-in error check. I always glance. The front number better add to 52. The back numbers better add to the number of cards I'm picking, which is 5. What do you get? Sorry? Answer? What did you get? 4, 5, 1, 2. Is that right? Now, again, Karn, I need to point out, that is not the number of ways to get 3 of a kind. That's the number of ways to get 3 kings. Oh, but if you don't write this down, that's the number of ways to get 3 of a kind, because you can get 3 aces, or 3 twos, or 3 threes, or 3 fours, or you can do it 13 different ways. Okay. 4 aces. 4 aces, good hand or bad hand? Very good hand, so I'm expecting a small number. 2 more and we're done. What's my bucket going to look like? What am I going to have as my subcategories or as my subcommittees in my bucket? Aces and not aces. Try this one on your own. I'll do it up here. Let's see if we get the same thing. I can do this one in my head, and I'll tell you how in a second. Is it 4 choose 4, 48 choose 1? Before you start typing, can you just type 4 choose 4? What's 4 choose 4? What's 5 choose 5? What's 6 choose 6? Here's what you're really saying, by the way. How many different groups of 4 can you form if you're picking all 4 of them? One group. How many groups of 5? So n choose n, anything choose itself, is just 1. What's 48 choose 1? Just type that in. What's 50 choose 1?
50.
So this one I can do in my head because I know 4 choose 4 is 1, and I know 48 choose 1. I know anything choose 1 is just anything. It is 48, yes?
Yes.
Now, that's not as useful as it used to be. Back when we used to use the TIs, I taught the kids all these shortcuts because as Zach found out, these are hidden in a sub menu somewhere and it doesn't stay on the screen. And so every time you were doing one of these, you were hitting like 20 buttons to get to there. So my kids memorized some shortcuts. Here on the Casios, you guys can keep these on your screen. So I'll show you the shortcuts because I'm a nerd, Oscar, but it's up to you if you learn them or not. Last one. 5 cards of the same suit called a flush. Well, we kind of did it at the very, very beginning when we did, what was the first thing that we did?
All diamonds.
Okay. All diamonds was what?
5 cards with a cross.
Yeah, no, what was the answer?
1,287.
1, 2, 8, 7. That's diamonds. Don't write this down. Write that down, but then don't write this next bit. What else could I have gotten instead of diamonds? Or clubs. Or, don't write this down, spades. Or hearts. Can you think of a shorter way to add 1, 2, 8, 7 4 times? Oh, so another way you can write this down, we could actually bring the fundamental counting principle. We could say that's how many ways there are of getting a flush in diamonds, and first you have to pick a suit, which is 4 choose 1, or just times by 4, because that's what 4 choose 1 is. From 4 suits, choose a suit. And then you got 1,287 ways of getting the same card. What is 4 times 1,287?
5,148.
That's how many ways there are of getting a flush. What are the odds of getting a flush? 5, 1, 4, 8, divided by, from 52, choose 5 cards. There's the probability of getting a flush. Pretty small, 0.00019. Okay. So that's how, we haven't done probability yet. That's next unit. So we'll revisit some of this in the next unit as well, which also means, by the way, Carson, if you don't get this unit, it's going to hammer you next unit, because next unit we're also going to count without counting to do gambling odds. What's your homework? Number 1, we are going to assume in pizza that you don't care when the topping is added. You only care if the topping is added. We're going to assume pizza is a choose. Okay? Number 2, skip 3. Number 4. 5 says basketball. I don't even need to read any further. Okay? So, card questions. 6, absolutely. Now, 6 is only looking at the face cards, so you're only looking at 12 cards. 7, card questions. For each of them, sketch a quick bucket. It takes 1 second, but hopefully you're seeing it really cuts down on your thinking. Ten. 12. So you got about 25, no, sorry, 15, well, 18 minutes. I was trying to get you about 20 minutes, went a little longer.